Okay, access control list. Access control list. Okay, so this is, or it's also called ACL. The short form is ACL. ACL. Okay, so now it's actually a list. It's actually a list. During, or say, this list is used to control the accessibility. It is used to control the accessibility. Suppose that I'm given a list. I'm given a list. Okay, I'm given a list here. Suppose it says Rakhu. Rakhu can enter the class. Suppose just a list to control your accessibility. Suppose that you guys haven't paid the fees. Okay, then just as an example. Okay, nobody's gonna like throw you away. Okay, now Rakhu can enter the class. Now Susmit, suppose he's not allowed to enter the class. Okay, now then I can tell Deva, do not enter the class. Now Anish, he can enter the class. Now I can tell like this as well. Say Anish and team. Anish and his team, a group of people, should not enter the class. I can tell like that. Okay, so now what I'm going to do is, when you guys are coming to the classroom, this is the door. When you guys are trying to enter into the classroom or while getting out of the classroom, I can filter you. Okay, so I can filter based on this list. And if at all you are not allowed to get inside the classroom or go outside the classroom, you will be denied. Okay, similarly, the traffic, the network traffic can also be denied or permitted using a list called access control list, which is configured in the router. Okay, so now let me draw a figure. So this is the figure. So R1, R2. Okay, and so let me take one diagram here, guys. Just let me open. Okay, now if at all you got two routers and you got a LAN here, you got a LAN, so and another LAN here. So what you're going to do is you're going to restrict the communication between the devices. So you will create a list, and list is of two types. List is of two types. One is called numbered list. It's called numbered list. Obviously you can guess. The numbered list means you can number it. You can number it. Means list number 1, 2, 3, 4 or 100, 100, 200, like that you can name it. Okay, so that's the numbered list. Now obviously you will have the next one is called named list. You can name the list. Okay, so test list or say deny list, some name you can give, whatever be the name you can give. Okay, now in the numbered list itself you got two types. Again you got two types. The first is called standard numbered ACL. Standard numbered ACL. Okay, now the second one is called extended numbered ACL. Standard numbered ACL, extended numbered ACL. Okay, similarly the named list also you got two ACLs. Okay, named access list also you got two types. Obviously you can guess. Standard named ACL. It's standard. Previously it was standard numbered ACL. Here now it is standard named ACL. And the next one is extended named ACL. Okay, standard named ACL, extended named ACL. So first let me tell you what is the standard ACL and extended ACL. Standard ACL means you can filter the traffic based on only the source IP. Only the source IP. Okay, suppose I'm just telling whoever is coming from place ABC should not enter into the class. Okay, so the source is being safe, or the source is used to filter. Okay, from and to address is there, and the source, based on the source IP, you are filtering the traffic. If at all the machine 10.0.0.100 is sending the traffic, it should be filtered. So 10.0.0.100 is the sender, or it's the source. You're not mentioning the destination, you are not mentioning the port number, nothing you are mentioning. Clear? So that's the standard ACL. Now extended ACL means you're using extended things here. You're using extended things. That means you can filter based on the source IP, you can filter based on the destination IP, you can filter based on the protocol, you can filter based on the sub protocol as well. Using these parameters you can block it. Okay, source IP, destination IP, protocol, and sub protocol. Okay.
Yes.
Now, yes. Okay. Now, guys. Now let me tell you. Here, you're gonna study all the four ACL: standard numbered ACL, extended numbered ACL, standard named ACL, and extended numbered named ACL. Okay, so first I'll be teaching you standard ACL first, standard numbered and standard named. Then we'll be going with extended numbered and extended named. Okay, so now before studying again the named ACL, okay, or this ACL, you will have to study the rules of ACL. You will have to study rules of ACL. So let me define the rules of ACL here. Rules of ACL. Okay, now the rule says, so here each entry, so let me show the diagram here. Let me take the GNS tree. Suppose this is the diagram, this is the topology that we have. Okay, now this one. Okay, just a minute, guys. Can you read it?
Yes.
Okay, so in that case let me just, okay, so here you got a LAN, here you got a LAN. Okay, and this LAN says, say here again, where is the epic pen? Okay, so now in this LAN I got some requirements. I'm gonna create a list so that I can deny these machines, I can permit these machines, permit, deny, and permit all of this. I can do the list here. Okay, so what I'm gonna do is, first you will establish the connectivity. So here you will do the routing and all, which is already pre-configured here. Okay, so after doing routing, then we are gonna say, we'll check whether these machines are able to communicate with each other, whether the communication is there or not, we'll check it. And after that we're going to create the list. So while creating the list, let me tell you here, so the list says I want to deny 192.160.10.0 to 10.127. It says 128 machines need to be denied, a group of machines need to be denied. Now 100 and 101, two machines need to be denied. Now 32 to 47, 16 machines need to be permitted. Now this one machine and one machine, and rest says the rest should be permitted. Okay, so now before writing the ACL, again let me tell you, if at all this is the list needs to be mentioned in a specific order. The list needs to be mentioned using a specific order. Okay, so in the list you have entries like this. These are the entries. So now, so if at all, suppose that I have my requirement permit 192.160.10.5. 192.160.10.5 needs to be permitted. Okay, and now if at all this machine 10.5 is trying to communicate, 10.5 is trying to communicate, so the router will receive the packet and router will check the packet, and he will understand that the packet is from 192.168.10.5. Then he's going to check the access list here. He's going to check this access list. When he checks the access list, he is going to process from top to bottom order. He's going to process it from top to bottom order. So he's going to check whether, say, anything is mentioned, 192.168.10.5 is mentioned or not. Okay, whether it is mentioned here, guys.
No. It's mentioned a range.
It is mentioned a range, and let me tell you, this range includes 10.5 also. This range includes 10.5 also. And what does it say? It says deny. It says deny. So what happens is that, so you got a match here. You got a match. And the respective action will be taken. That means the packet will be denied. But actually my requirement is this machine should communicate. Getting it? So my requirement will not satisfy. The machine 10.5 will not be able to communicate. That means the packets are processed from top to bottom order. If at all a match happens, then they will not check the later entries. The next entries they will not check. Clear? Similarly, so again, similarly, let me tell you, 192.168. So this one, 32 needs to be permitted. 32 needs to be permitted. So if at all this entry is mentioned as a third entry and this is mentioned as a first entry, so when the packet 32 is sending a packet, when it reaches, they are going to check the first entry and where the match will happen and the deny statement. So the 32 will not be able to communicate. So we have to write it in a specific order. Okay, the order will be written in this format. So first you will check the number of machines here. You will check the number of machines. Here you got 128 machines. Here you got 2 machines. Here you got 16. Here you got 1 machine, 1 machine. Okay. Now you will be writing the order in such a way that you will write the least number of machines first. You will write the least number of machines first. So least means you can either write it this one or you can write this one. That depends upon your choice. Okay. So now let me write this as the first entry. Deny 192.168.10.40. Then this, let it be the second entry. Okay, and which one will be the third entry?
Second one.
Second one means 100 to 101 you got only 2 machines. So that will be the third entry. And this will be the fourth entry. And this will be the fifth entry. And at last you will mention permit all others. The rest, whichever traffic it's not mentioned, permit all others. Okay, if you didn't mention this, then the unspecified traffic will be blocked. The unspecified traffic will be blocked, and that is called implicit deny. That's called implicit deny. So if at all you have the requirement to permit all the others, then as the last entry you will permit all the others. Clear, guys? Okay, so this will be the last entry here, and that is called, or that will be the sixth entry. So we'll be writing it in this order. Okay, so now let me take a screenshot of this one. Okay, now so here this is how you're gonna write. And now let me tell you, so we have, say suppose I'll be telling you the command syntax and all later. Okay, now that we have written the ACL, we have written the ACL. After writing the ACL, we will bind the ACL to an interface. We will bind the ACL to an interface. In the previous example I told you, so if at all I have a list of the students who have not paid the fees, right, I'll be filtering it. Where I'll be there? I'll be there in the, say, door. By the door I'll be there, and I'll be filtering it out, right? Similarly, you will have to either filter or you will have to bind it to an interface to take effect. So either you can bind it in serial 0/0 or fast internet 0/0. Now while binding you can mention the direction also. While binding you can mention the direction. You can mention the in direction or the out direction. The in direction or the out direction. Okay, so the direction will be specified based on the source. Based on the source. Suppose this is the source here. 192.168.10 dot is the source here. So when the source is sending the packet, it is sending the packet into the fast Ethernet. And the packet will be going out of serial 0/0. So you can either bind it to the fast Ethernet as in, or you can bind to the serial interface as out. Clear, guys? So this is how you're gonna write it. Okay, now again let me tell you. So these are the rules of ACL. Now before going to ACL, before doing the ACL, so here let me tell you how to represent these, okay. So we'll use this. So I can tell, just in the example I've told Anish and his group, Anish and team. Okay, similarly I can represent this group here. I can represent this group using something called wildcard mask. So using the wildcard mask, you can group the machines. Okay, so let me tell you how you can use wildcard mask to group the machines. Okay, so now let me take paint and let me tell you. Suppose you got a network. So 100.1.2.0/24. So you would have found out the wildcard mask in OSPF, right? Where I would have told you, so if at all you have /24, the subnet mask. What is the subnet mask? Say 255.255.255.0. Okay, it will be the reverse of this wildcard, subnet mask. So in the network portion you will write zeros, and the host portion you will write 1. But you can use that. You can write it like that for the entire network. So if it says the subnet mask is 255.255.255.0, the wildcard mask will be 0.0.0.255. There's actually a method with which you can find out it. Okay, so now let me tell you. So here the wildcard mask is 0.0.0.255. So and the machines here represents like this: 10.1.2.0 10 or 100.1.2.255. Get it, guys? So this is the group, and for this group this is the wildcard mask. Okay, now let me tell you the actual method on how to calculate the wildcard mask. Okay, so if you have this group 100.1.2.0 to 255, or let me tell you 100.1.2.255. okay, so you will write the address here: 100.1.2.0 and 100.1.2.255, and you are gonna check from which octet onwards the change is happening. Almost like the summarization. Okay, in which octet onwards the change is happening. Of course, you can see in the 4th octet onwards the change is happening. So the 3 octets will remain constant, right? So 100 dot will remain constant here. Okay, all the 3 octets will remain constant. So 100.1.2. remains constant, and let me expand the 4th octet. So 00000000. Okay, and the next one is 100.1.2.255. So I'll be writing 11111111. Okay, now we are going to check from which bit onwards the change is happening. From which bit? That means you can see here from this bit, from the 25th bit onwards the change is happening. So that means I've drawn a line, and to the left side of the line you have network bits, or to the left side of the line you will make it as zeros. You will make it as zeros. So everything will be made 0 here, and to the right side you will make everything as 1. Okay, so what's going to happen is that, so you have got 24 zeros here. So the value will be 0.0.0.255. This is how we'll calculate the wildcard mask. Getting it? Okay, so you can note it down. Okay, you can note it down. Let me pause recording here. Okay, so guys, I want you to find out the wildcard mask for these machines. Okay, hope you can read, right?
Yes, miss.
Okay. So, oh, this one is bad. Okay, I suppose this is good. So, you can find out the wildcard mask for these. Okay, and let me give you some more questions also. Okay, so now 28.128.0.0 to 28.128.3.255. Okay, and the next one 158.42. Say suppose 160.0 to 158.42.176.255. Okay, this is the first question. Second question, third, fourth, fifth, and sixth. Okay, if you have any doubts, please ask. I'll be here only. Okay. Yes. Okay. So guys, so the last benchers, till how many questions you have done? 4, 5, 2 questions. So the first question Sajin will tell the answer because he has already completed the first. So guys, again, if at all you want to discuss the questions, let me know. Which question you are stuck, which question you want to discuss, let me know. Okay. So yes, Sajin, what is a wildcard mask here? 0.127, which is right. Okay. Now who's gonna tell me the second one? Ashwin. Yes. 0.000. Nope. 1. Let me tell you how to do it. So I told you, say that this is the question. Okay. So 192.160.10.100 and 101. Okay. So let me tell you, you got 100 and .101. Okay. So in which octet the change is starting? 4th octet the change is starting. Okay. Till the 3rd octet everything is same. So 192.168.10.100, and here we'll be writing 192.168.10.101. So you know in the 4th octet the change is starting, so let me convert it to binary. So when I convert it to binary, this value will be 100. It can be written like this: 0 1 1 0 0 1 0 0. Okay, this how you will write 100. Now 101 will be written like this: 0 1 1 0 0 1 0 1. Okay. Now, so here 192.168.10 is common, and here 192.168.10 is common. So in the 4th octet, in where the change is occurring? Ashwin. In the 4th octet, in the which bit onwards the change is happening? 29 or 30 or 31 or 32. Again, here you got 0 and 0, which is same. Here you got 1 and 1, again 1 and 1, 32, 31. Okay, we'll check 1 and 1, 0 0 0 0 1 1 0 0 0 1. Okay, so in the last bit the change is happening. Last bit the change is happening. So what you're gonna do is you're gonna make all these bits as 0. All the 31 bits will be made 0. Okay, and the last 32th bit, 32nd bit will be changed as 1. Getting it? So the answer will be 0.0.0.1. This is how you will get the wildcard masking. Okay. Yes. Once again. So you're gonna first check in which octet the change is happening. The change is happening in the 4th octet. And in the 4th octet, from which bit onwards the change is happening. Okay, from bit. So this is the 4th octet. I have just expanded it. Okay, when I expand it, the 100 I can write like this, and 101 I can write like this. And now you can see, say 0 is common, 1 is common, 1 0 0 1 0, up to there it is common. Okay, or up to there you have the same values, and in the last octet you can see the variation or the change. So the change is starting in the last octet, 0 and 1. So that means just before that I have drawn the line and to the left side of the line I have made it as 0, and to the right side of the line I have made it as 1. Clear? Got it? Okay. Subhash, getting it? Okay, I suppose you have. Yes. Okay, now what about the next one, guys? 32 to 47. Who has done it? 0 0 0 15. Very good. Answer is 0 0 0 15. Difference? Nope. Now let me tell you guys. Guys, you can listen here. If you take the difference, so in some question it will be right. Say here you have 128 machines. So if you write 0 0 0 127, it is right in this case. Okay, and if you write, you got 2 machines here, so if you write 0 0 0 1, it is also right in this case. And if you write 32 to 47, you got 16 machines. So if you write 0 0 0 15, or when you decrease it, 47 minus 32, it is 15. Okay, you can write it like that in this case, but not in every case. Okay, so in some cases, say I'm not going to discuss those cases, but because you will get confused. Okay, so in some cases you will not get it exactly like that. Getting it? Okay. Now what about the 4th one? Any of you did the 4th one? 0 dot 3.255. Which one? The 4th one or the 5th one? 5th. 4th one, anyone did it? Say, I suppose Raghu was telling an answer, right? Yes, Raghu.
0 dot 0 dot
0 dot 0 dot 0 dot? Nope. Nope. 3, 4, 5, 6. Yes, guys. Now, so online guys, any answers? Nope. 0 0 0 255. Nope. Sorry woman, you got it wrong this time. Okay, let me tell you, it's very simple. Nope. Okay, so this machine, you only have a single machine, so you can write it like this.
92.
Yes, Salman, you are right. Okay, so 192.168.10.5 to 192.168.10.5. You can write it like this. So that means the entire 32 bits will become common. The entire 32 bits will become common, or it is same for all the 32 bits. So all the 32 bits will become 0. 0 dot 0 dot 0 dot 0. That's it. Getting it? Okay. So this is 0 dot 0 dot 0 dot 0. Okay. Yes, Rakesh. The next one you are right. Okay. So now the answer to the next one. So guys, you are told the online guys can answer, right? The online guys are answering without even asking, they are answering. Okay, here, but in offline guys, okay. So now here it is 0 0 0 sorry 0 0 3.255. Okay, 0 0 3.255. Okay, want to discuss that? Sure.
Yes.
So then Susmit will answer. I mean, Susmit will tell how it became 0 0 3.255. Yes, Susmit. Second octet? Third octet is 3. So in the third octet, the change is starting. Right. So in the third octet, from which bit onwards the change is starting? First octet. Sorry, first bit, second bit. Last in the second arc. Okay. Yes, that means the sixth. Till the sixth bit, you have the same value. Okay, I suppose it's a guess. Is it? Okay, so it's from the sixth till the sixth, it is same. From the sixth, you have the change, right? So it will be 0.03.255. Now, who will tell me the last one?
0.015.
Yes, this one is last is 0.15.255. Anyone want to discuss this question? The last one? No, sure. Raghu, want to discuss? Okay. So what is that? Say, let me tell you. This is the question here. So let me write it down here. This is the question. Okay. Now, so 158.42.160.0. Okay. So guys, can you just turn it off if everyone is okay? Okay. Turn it off. Okay. So if at all you're feeling hot, then you can turn it on later. Okay. So now 158.42.175.255. Okay, so now you can see in the third octet the change is happening. In the third octet the change is happening. So if at all in the third octet the first two octets will be common. Okay, so 158.42 is common. Now let me expand the third octet. For 160, if you expand, you're gonna get 101.0.0.0.0. Okay, now if you are gonna find out the binary for 175, it is 101.0.1111. Okay, now here dot 0 and here dot 255. So now you can see from this bit onwards the change is happening. Okay, so till this bit you will make everything as 0. So 0.0.0000. Now this will entirely become 1. So here 1 1 1 1 and the 8 bits in the fourth octet will become 1. So if you calculate, then the value is 0.0.15.255. Clear? Okay. So this is how you're going to calculate the wildcard mask. Okay. Now, so I suppose you know how to calculate the wildcard mask, right? Now we shall go with the ACL configuration. So first we will go with the standard ACL. We'll go with the standard, or you can write the heading standard numbered ACL. Standard numbered ACL. Standard numbered ACL. Okay, so now let me tell you. So this is a diagram. Okay, so now let me make it bigger. No, unfortunately it is not going. Okay, so now, okay, so here, okay, so now I have written the order. First I told you this is the order. Okay, so we'll be writing this number. So here you can see you are talking about the standard ACL here. We are talking about the standard, where in the standard ACL we'll be filtering based on only the source IP. Here you can see the source IP. Deny 192.168.10.40. So that means deny the traffic from 192.168.10.40. So the destination IP, the protocol and everything is not mentioned here. Okay, so what you're going to do is you're going to go to this router. You're going to go to this, say R1 here. Okay, say let me take R1. Okay, just let me close the previous diagram, guys. Okay, so now we're going to go to R1, and in R1 I'll go to the config mode. Now we are going to do the standard ACL, standard numbered ACL. Okay, so you will give the command access-dist. The command is access-list. Then you will mention the ACL number. ACL number. If it's for standard numbered ACL, the number can be from 1 to 99. It can be from 1 to 99. So now let me give a number, suppose 20. Let me give a number 20. Okay. Now then we will give, say, what is the first statement says? The first statement says to deny the traffic. To deny the traffic. So we are going to give the keyword deny. Okay. Access-list 20 deny. Then what we are going to give is, we are going to give the IP address. We are going to give the IP address here, 192.168.10.40. Okay. So we are going to give the IP, which is 192.168.10.40. And the wildcard mask. What is the wildcard mask if the value is only 10.40, or if you only have one machine? What is the wildcard mask? 0.0.0.0. Clear? Yes. This is how you're gonna end. Okay. Now, so if this is the this is how you're gonna do the command, can you tell me the next one? Okay. So the next says permit 192.168.10.5. So in that case, can you tell me the command here, guys?
Access list 20 permit.
Access list. Getting it, guys? Access list 20. Okay. Now we need to permit. So we'll give permit. Then what is the IP here? Say, where is it? What is the IP here? 192.168.10.5. Okay. So we'll be giving that IP 192.168.10.5. And what is the wildcard mask? 0.0.0.0. Okay. This is how you will give the ACL. Now, what about the third entry? So this is the third entry. How will we mention it? Access-list the same. Okay. Don't consider the group now. You can tell the first thing. What is it? Access-list 20. Then permit. Okay, we are gonna say, where is it again? We are gonna permit it. We are gonna permit it. So we are gonna give permit. Okay. Then what is the starting IP here, guys? The starting IP is 192.168.10.100. So we are gonna give 192.168.10.100. Okay. Then you are gonna give, say, after this, you are gonna give the wildcard mask. What is the wildcard mask for two machines? Or if at all the wildcard mask is 100 and 101. 0.0.0.1. Okay. So you will mention that 0.0.0.1. Clear? Now, what about the fourth entry? Permit. So you can tell the full one. Access-list 20 permit 192.168.10. So what is the entry here? This is the fourth one. 10.32 is the first one. So we'll give 10.32. And then the wildcard mask is 32 to 47. So the wildcard mask is 0.0.0. It's 15. Okay. If you calculate, I suppose that's the third question that I've given you, right? So here, where is it? So not here. Okay. In the paint, somewhere in the paint, I suppose this is it. Okay. So in the question, yes. So from 32 to 47, the wildcard mask is 0.0.0.50. Okay. Now, what about the fifth one? Fifth one, you can tell me.
Access list.
Okay, the command, let me take it. Okay. Now, again, it's gone. Yes, access-list 20. Okay, deny. Access-list 20 deny 192.168.10.0 0.0.0.127, because here we have a wildcard mask of 127. Clear? Okay. Now, so we have mentioned almost everything. Okay, so this one we mentioned, and the last one remains. So for the last one, let me tell you, we got a specific command. The command is, let's say, it is to permit all the others. Permit all the others. So the command is whoever is unspecified, permit them. Okay, whoever is unspecified, permit them. So here we have not specified about the IP 200. Okay, or 250. We have not mentioned the IP 200 or 250. So if at all the 200 or 250 is sending a packet, then that will be blocked. Those packets will be blocked. So I want to like permit all the others, means whatever is not mentioned, 200, 250 and all, if it's not mentioned, permit them. Clear? So the command is access-list 20 permit. It says to permit everyone, right? Permit any machine, that's it. Permit any. So this is the command. Clear? Okay. Now, after giving all the commands, I told you, you need to bind this to an interface. You need to bind this to an interface. So binding to an interface, let me tell you how to bind it. Okay, so we'll go, suppose we can either bind it to, so where's the diagram? Either you can bind it to fastInit 0/0 or you can bind it to serial 0/0. I suppose you can read it at the back, right?
Yeah.
Okay, so you can say bind to fastInit 0/0 as in. You can bind to fastInit 0/0 as in, or you can bind to serial 0/0 as out. Okay, so now let me bind as in to f0/0. FastInit 0/0, I'm going to bind it as in. So what I'm going to do is that I'm going to go inside that interface. So interface fastInit 0/0. Then I'm going to mention IP access hyphen group. The command is not access hyphen list, the command is access hyphen group. Then the ACL number, which is 20 here. The ACL number which is 20. Then we'll mention in or out. Here it is in. So this is it. Clear, guys? Okay. So this is how you're gonna mention it. Okay. Now, if at all you want to see the ACL created, you have done the ACL. If at all you want to see this ACL, you have the command do show IP access hyphen list. The command is do show IP access hyphen list. If you enter that, you can see the access list 20. And what does the access list 20 says? This is. Okay. Now, deny 192.168.10.40, permit 192.168.10.5, and permit, then permit, deny. At last you have permit any. Clear? Okay. Now, shall we check it, guys? Okay. Now, if at all you want to check it, you're going to go to each machine. So here we need to permit 192.168.10.5. So we got .5 machine here. The PC1 is .5. So if you go to PC1, so if at all you go to PC1 here, it is having the IP 192.168.10.5, and you're going to ping to this IP 172.172.16.0.2. Okay, so let me ping 172.16.0.2. we need to get the reply. Okay, so because we have permitted this one, permit 192.168.10.5. so if you ping from 5, you're gonna get the reply. Let me check it. Yes, you can see you're getting the reply. Yes, so 85 bytes from 172.16.0.2, you're getting the reply. Okay, everyone. Okay, now if at all, say the next requirement says to deny 192.168.10.40, you need to deny it. So 40 is PC2. Shall we check it?
Yes.
Okay, so PC2 is there. So if I ping from this PC2, so PC2, if I ping, let me check. Okay, so ping this one 1 and 2. Yes. Now you're getting some messages. What is it? 192.168.10.1, which is the router, which is our router. Router says communication administratively prohibited. Communication is administratively prohibited. That means, say you will not be able to, or your packets are being blocked by this ACL. Clear? It's your packets are prohibited. So you have denied it. Clear? Now again, the next one, permit 100. Permit 100. So the PC3 is 100. If at all you ping from PC3, then you will not, you should be getting the reply. Shall we? Okay, so let me go to PC3 here. So PC3 is 100 here, and if you ping, sorry, not this one. You're getting the communication. You're getting the reply from 172.16.0.2. Clear? Everyone? Now the last thing. So permit all others. Permit all others means whoever has unspecified needs to be permitted. So here you got a machine which is unspecified dot 250. So if you do a ping from this 250, you should be getting the reply. Okay. So here let me go to 250, which is PC6 here. Okay. PC5 here. Okay. So ping from the PC5, ping 172.16.0.2. Yes, you are getting the reply. Any doubts? Clear? Okay. This is how you're going to do the standard numbered ACL. Now let me tell you the the commands for standard named ACL. Okay, it's simple. So let me just take the router and let me just execute do show IP, do show history. Okay, so this command you can see these are the entries that you have done. Okay, so let me take the notepad. So what you're gonna do is first you will go to the config mode. You'll go to the config. You'll go to the config mode and you will mention something like this: IP access-list. IP access-list. Then you will mention the keyword as standard. You will mention the keyword standard. Then you will give the ACL name. Suppose we are giving test. We are giving test. Then what you are going to do is, or you will be inside the standard or the standard ACL. Okay, config hyphen std hyphen NACL. Config hyphen std hyphen NACL means we are the standard named ACL. Okay, then you're gonna give the commands like this. Say whatever is there, access list 20 is there, say you're gonna delete it. Okay, and you're gonna give the rest of the command. Clear, guys? Okay, so you're gonna give all these commands here. So let me just show to you. So first let me give it IP access-list standard test. Okay, and you can see the prompt has changed to standard NACL, the named ACL. Then you're gonna mention all these commands here. Okay, all these commands are mentioned here like this. Now if at all you want to check it, do show IP access-list. You can see the test list has been created. Test list has been created, and you can see the entries also. Now let me tell you one more thing. So here you can bind the named ACL also. You can bind the named ACL. To bind the named ACL, the command is exactly same as that of the other one. We'll go to the interface. The command is like this. Where is it? We'll go to the interface, then we'll mention a IP access-group. Instead of 20, you will give the ACL name. You will give the ACL name. Then we will give the command in. We are binding it as in. That's the only difference. Clear? Okay. So this is how you're going to do it. The standard named ACL. Okay, this is the command to do the named ACL. I suppose you have understood, everyone, right? Okay. So shall we go to the extended named ACL? Extended numbered and named. Okay. So now, so let me close this one. Let me stop it. Then let me take another one. Open the project. So I hope you can see it, right? This also you can see at the back. Dekho? Okay. So now let me turn on the devices. I have the same diagram. Okay, the same diagram in the sense the same topology here, but I've just, instead of the standard ACL, I've just created I'll be creating the extended ACL. Okay. Sorry. So now, so here let me turn on the devices. Okay, again here also we'll go with the same order, or we'll go with the order here. We'll check the source machine, the number of source machine. So here, then when you check the number of source machine, you got 64 machines here. How many machines you got? 64 machines. So this is the source. Say deny HTTP, you have mentioned deny, and this is the traffic. This is the protocol or the sub protocol. Okay, then you have mentioned from 192.168.10.0 to 63. So this is the source IP. To the destination, this is the destination. Somewhere we have a web server .100. Okay, so you are trying to say do the HTTP service to that HTTP server or the web server. Okay, so now here you got the source machine, 64 source machines are there. Okay, now here you got 8 machines, 8, and here you got 4 machines. Here you got a single machine. Permit ICMP from 192.168.10.201 to say some IPs. So this 201 is a single IP. Okay, so only one machine, and here also only one machine, and this is the last entry. Getting it? Okay, so now suppose this is the first entry here, and this is the second entry. So we'll consider the least number of IPs or machines first. So here you got the first machine, the second entry, the third entry, the fourth entry, the fifth entry, and at last you will be writing this permit all others. Clear? Okay, so now let me just take a screenshot of this one. Okay, so now, oh, just give me a moment again. Yes. Now we are going to do the extended one. Okay, so to do the extended one, I told you we'll be telling the source IP, destination IP, protocol and sub protocol. So here let me tell you the first. So let me go to R1 here. Okay, here you have R1. We'll go to R1 and we'll mention the commands. So the command syntax will be like this. We'll go to the config mode, and there we'll mention the command like this. So which is the first entry? This is the first entry. So to the first entry we'll mention it like this. Okay, so we'll go to, okay, just give me a moment. Okay, so the command will be like this. Again, it's going. Okay, so we'll mention access-list. We'll mention access-list. So we have to permit here. So you will mention access-list. Then here we are going with a numbered ACL. So for extended ACL or extended numbered ACL, you can give the number from 100 to 199. Okay, suppose I'm giving 150 here. 100 to 199, here I'm giving 150. Then I can mention whether it's permit or deny, depends upon the traffic here. The first traffic says it needs to be permitted. Okay, so where I'll be permitting it. Permit. Then we'll mention the protocol here. Sub protocol will be mentioned later. Here we'll mention the main protocol, which is TCP. So when you press question mark here, you got many protocols here. You have many protocols: AHP, AGRP, ESP, GRE, ICMP, IGMP, IP, IP and IP, NOS, OSPF, PCP, PIM, TCP, UDP. You got multiple protocols. So here you're gonna block or you're gonna permit the TCP here, because here I mentioned TCP. Okay, so we'll mention TCP. We'll mention the traffic TCP. Then we'll mention from where to where. From where? 192.168.10.28. So the command is 192.168.10.28. Then the wildcard mask is 0.0.0.0 because we only have a single machine. Then we'll mention this destination IP. So destination IP here is 172.16.0.53, single machine. So 172.16.0.53. Okay, now everyone getting it? Okay, then you will mention, so then you will mention the subprotocol. But here in this entry, the subprotocol is not mentioned. The subprotocol is not mentioned. Just mention TCP. Clear? So we'll wind up. Okay. Okay. And before that, one more thing, guys. Before that, again, or a single machine, we need to give the wildcard mask 0.0.0.0. Clear? Okay. This is how you're gonna mention the commands. Command, I'll let you write it later. Okay. Now the next command. So next command again, what is the second command here? The second command is permit ICMP. Okay, so we are gonna mention access -list. 150 is the number. Okay, then we'll mention permit. The protocol is ICMP. Yes. Then we have the requirement 192.168.10.2012 172.16.0.31. Okay, so 201 is a single machine, and here you got 32 machines and all. Okay, so you will mention it like this here: 192.168.10.201. Okay, 192.168.10.201 0.0.0.0. Okay, then you're gonna send it to 172.16.0.0 to 31. 172.16.0.0 to or to 31 means wildcard mask of 0.0.0.31. Clear? Okay. So this is the second entry. Okay. Now going with the third entry. So deny ICMP. Deny ICMP. So again, access -list 150. Then deny, then the protocol. Okay, so deny ICMP. Then the source IP, wildcard mask, destination IP, and the wildcard mask. Source IP means 200 to 203. So 192.168.10.200 0.0.0.3. Okay, now yes, to which one? 172.16.0.0 to 31. So 172.16.0.0 to 0.0.0.31. Clear? Okay. So 0 to 31. Now let me tell you guys. Now permit HTTP. Permit HTTP. So I'll be giving access-list 150. Now permit. Now here you can see HTTP is the traffic. HTTP is the traffic. So if at all I try to give HTTP, it's not coming. It's unrecognized command, because let me tell you, HTTP is the subprotocol. HTTP is the subprotocol. So here in the transport layer, HTTP uses TCP as the protocol. HTTP uses TCP. So here you can see TCP and UDP. You do not have HTTP and all. Okay, so in the TCP, HTTP will come. Okay, so you will give TCP as the protocol here. TCP. Okay, then you're gonna give say the IP address here, which is 192.168.10.027. So we'll mention 192.168.10.00007. Okay, then the destination is to a single machine, 172.16.0.100. So 172.16.0.100 0.0.0.0. Okay, but we have just mentioned the protocol TCP. We didn't mention the exact subprotocol. So to mention the exact subprotocol, so TCP will be having lot of subprotocol. TCP will be having lot of subprotocol. SMTP. Okay, maybe HTTP, maybe Telnet. You will have many subprotocols. So what you're gonna do is you're gonna mention the port number. So here let me tell you, if I tell you that for SMTP the port number is 25, for HTTP the port number is 80, for Telnet the port number is 23. So in TCP or TCP equal to 23. TCP equal to 23. That means TCP is the main protocol and the port number used is 23, which is Telnet. Telnet's port number. Okay. Similarly, if you mention TCP equal to 80, TCP equal to 80 means 80 is the port number of HTTP. So if at all the HTTP is there, you will be giving equal to here at last, equal to EQ. Okay, then 80. Clear? So now again let me show to you. If EQ question mark, if you press it, you can see many subprotocols here, and you can see www, which is HTTP, and this is the port number 80, and you got Telnet with a port number of 23. Okay, you got some other protocols also, POP3 with a port number 110. Okay, and you got another protocol here, it might be familiar to you, FTP with a port number of 21, and you got, say, like that, you got many protocols. So if it is UDP, okay, or if it is DHCP, that if at all you want, you can turn on the AC. Okay, so if it is DHCP or DNS traffic that you want to block, you will be going with, say, UDP. You will be going with the UDP, because DHCP and DNS, they will be under UDP. While teaching you those things, I mean the the transport layer and all, I might have told you. Okay, now, so the next command, what is the next command? This is the next command. So here, okay, deny HTTP from 192.168.10.0 to 63. Okay, 0 to 63. So let me give the command here, access-list, then 150 deny which traffic is HTTP. So the main protocol is TCP. TCP, then from where to where? From 192.168.10.0 to 63. So 192.168.10.63. And with the wildcard mask, if you calculate, the wildcard mask is 0.0.0.63 only. Okay, try to calculate the wildcard mask later. Okay, then let me tell you, to a single destination, which is 172.16.0.100.
That is 10.0.
Okay, yeah, 10.0. Okay, so to a destination, what is the destination? Yes, 172.16.0.100. Okay, so 172.16.0.100. Now equal to, say here it was HTTP. So equal to, say, either you can give the port number. Okay, you can give the port number. I suppose previous command I didn't give the port number. Okay, so if at all, so just give me a moment. Okay, equal to 80. Okay, now, okay, here also it is equal to 80. Clear? Okay, it's not a subnet mask, it's a wildcard mask. Very good. So for the destination also you need to give the wildcard mask, which is 0.0.0.0. Okay, yes. And if at all you want to see the IP access list, then the command is to show IP access hyphen list. Clear, guys? Okay. And if at all you want to say again, this also you need to say bind it. So you can either bind it to, so here the source is here. The source is here. So either you can bind it to in for f0/0, or you can bind it as out to serial 0/0. So let me bind it as out this time. To serial 0/0, let me bind it as out. Okay. So I'll go to the serial 0/0 interface serial 0/0. The command is IP access hyphen group. The ACL number is 150 out. Clear? The same command, binding is the same command. Okay. And one command we have missed it out. What is the command, guys? This one, permit all others. We didn't mention that, right? If you want to mention it, the command goes like this. You got a specific command for that. The command is, say, access hyphen list 150. You need to permit everyone from whatever be the source to whatever be the destination, whatever be the protocol, you need to permit. So permit IP. Permit IP means any protocol. You need to permit any protocol. So permit IP any, from any machine to any machine. Clear? Okay. So do show IP access hyphen list. It says, you can see even at the last entry you can see permit IP any. Clear? Okay. Now shall we test it? Okay. Now if you want to test it here, say you will be testing it like this. Say we are gonna check the ICMP traffic. We're gonna check the ICMP traffic. So guys, if you're feeling hot, then you can turn it on, no issues. I'm now okay. Okay. Now, so here let me ping from 192.168.10.201. 2012. So here you got .2 here. So from 201, which is PC1 to .2. Okay. So that 2012.2 is permit here. This is permitted. Okay, so the PC1 should be communicating to .2, 172.16.0.2. So let me go to PC1 and mention ping 172.16.0.2. So here you should give, or you should get the communication. It is permitted. Okay, now Anish. Okay, now let me take a deny statement. The deny, so 200 to 203 is denied. Okay, of which 200 will take 200, which is denied to where? It is denied to 0.0231, which includes .2 also. So from 200 to 2 it should be denied. So let me take PC2 and again let me ping it. Yes, you're getting a message which says the router is saying yes, communication administratively prohibited. Clear? Now if at all you got any unknown packet, say suppose 250 to 250, here it is unknown or unspecified packets. Okay, here we haven't mentioned about this 250 to this 250. So if it is unspecified, then permit all of those. Okay, so from this 250 to 250 we are pinging. So let me ping from the PC3 to the next 250. Sorry, not here. .250. So here the communication should happen, and it is happening. So this is how you're gonna do the extended numbered ACL. Okay, if at all, and again, so I can, now that I have done the extended numbered ACL, let me give you extended named ACL. Extended named ACL. Okay, done guys, almost within 5 to 10 minutes. Or do you need a break for 5 minutes? No. Okay, so extended named ACL, the command is, we'll go, so do show history. Okay, so you got many values here. I suppose permit, okay, it's correct only. What happened was that So these commands EQ we have pressed tab and all, right, and we have say like incomplete command was there, some command I didn't mention the wildcard mask, and also some errors are there, so that's why. So this and all I haven't mentioned and somebody told me that I haven't mentioned those things, right? Okay, so just deleting the unnecessary things, that's it. Okay, so this is how you will do it. And now let me tell you, to do the extended name, the command will be IP access-list extended. Previously the command was IP access-list standard. Now the command is IP access-list extended. Then the name, suppose test or test list, some name we are giving. Then you can see we have moved into, previously it was standard NACL, now it is extended ext-NACL, extended named ACL. Okay, now that we will mention the commands, you can just delete this one in the front. Access-list 150, just delete it. Previously also we have deleted this one, right? So the same thing, whatever it was there we will delete it. Okay, and at last you got the command, say permit IP any. Okay, so now if you mention it, this is how you will do the okay, incomplete command, maybe this command, yes, it was an incomplete. Okay, this is how you will do it. Okay, now here if at all you want to see, again the binding command is the same. Okay, we'll go to that interface and IP access-group, instead of the number we will bind the name and in or out. Okay, binding is same for everyone. Then the command is do show IP access-list. That's the command to view. So here you can see the access list 150 is there and test list is the named ACL. Clear? Okay, and let me again tell you, so here you can see the numbers. Here you can see the numbers. These numbers are called sequence numbers. These numbers are called sequence numbers. Now if at all you want to edit an ACL, you can edit it. Okay, so suppose that I want to edit the test list, this ACL, so I'll go to the ACL now. Okay, the command is IP access-group, this is the command. Okay, extended test list. Okay, now that I want to delete the 40th entry, 40, if at all I want to delete the 40th entry, I can give something like this. I don't want to, or I shouldn't have to type everything, just type no 40, no 40. Then if you take do show IP access-list, you can see the 40th entry is deleted here. The 40th entry is deleted. Now if at all I want to add something in between these two, between 10 and 20, if at all I need to add an entry, I told you the order is important. If at all you want to change the order, or if at all you have misconfigured it and you need to reconfigure it, you can reconfigure. So if at all you want to add any value in between 10 and 50, I'm going to give a number, suppose 15 or 16 or 17 or 18, whatever the number is, I'm going to give it. Then I'm going to mention the command which is permit, suppose some random. Okay, permit IP 1.1.1.1, say just some giving random as an example. Okay, then 0.0.0.0, then 2.2.2.2, 0.0.0.0. Okay, 0.0.0.0. Okay, now if I want to check it, do show IP access-list. You can see, yes, it's there. Getting it, guys? So the 15th entry, it is there. Any doubt? So this is how you're going to do the ACLs. Okay, so what we have done is standard numbered ACL we have done, and I've given the command. I'll give you the command syntax. Okay, of standard named ACL. Then we have done the extended numbered ACL, and you can do the extended named ACL also. Clear? Any doubt in this? Paka? Okay. Then let me, yes guys. So yeah, somebody has pinged, why don't we do all these configurations on R2? Why did we choose R1? So you can do it on R2 also, no issues. Okay, I just mentioned R1 here. You can do it. So instead of mentioning this to R1, you can mention it to R2. No issues. Okay, you can do the configurations in R2 as well. And while doing the configuration in R2, make sure that for serial interface, the traffic that you are receiving in serial 0/0 is towards inward. So when you bind it, you need to bind it to serial 0/0 as inward. And fast unit 0/0, you can bind it as outward. Clear? Okay. So now let me stop recording.